Hi, this is David, and I'd like to share with you some inventions that I'm working on that are pretty exciting, and these are based on a project building solid-bodied violin family instruments. And what I'm going to describe today is related to the violin specifically. And one of the things that I surmised about the physical movements of violins and what gives them their unique characteristics is that, as you're looking at a violin here, this is all very symmetrical on the outside, but on the inside it's completely asymmetrical between the treble side of the instrument and the bass side of the instrument. And so all violin family instruments, cellos and basses and things like that, have a what's called a sound post, and it presses between the sound board and the back of the instrument, and it basically acts like a pin that couples the top to the back, and it makes that side of the face very, very rigid. It's basically like a rigid structure with that sound post there. On the other side of the top, underneath here, inside, is a brace that's called the bass bar. And when you're building a violin, you spend a lot of time carving that and getting it just right so that it offers some structure, but it allows for this side of the bridge to spring up and down a little bit. It has a bouncing motion, and having the sound holes here also sort of facilitates that movement. And what I realized is that if you could picture this being the bridge is literally pinned on this one side here, and then the other side is bouncing up and down. So the sound post is acting like a fulcrum point, and when you drag the bow across the strings, the bridge moves down, comes back up, moves down, comes back up, and is doing this rocking motion on this axis while you're playing it. And so it's completely asymmetrical in terms of the way the top is behaving and the motion of the bridge. And there's a lot of people making electric violin family instruments, and the bodies can be any kind of elaborate forms or structures, but commonly the body is just a slab of wood, and they put the bridge on there and stick a pickup under it, usually, is where you're going to sense that. But because it's just fixed on a block of wood, it doesn't have the ability to move, and the bridge doesn't. And I spent a lot of time thinking about how you could build a solid electric structure and having this rocking function, which I really feel is fundamental to the sound and the behavior and the feel of these instruments when you're playing them, is the fact that the bridge is able to rock back and forth like that. So I then built a proof of concept of how can I create that effect in a simple form. And here's the simple form. And so what we have here is we've got a spruce box. It's got a cedar top on it, but we've got a spruce box that on the treble side has a vertical wall, and on the bass side has a slot cut in it. And with this idea, the solid side here is basically rigid, doesn't move up and down at all, and the bass side of the bridge can move up and down and bounce around. And so by playing with this slot here, you can decide how much movement you want to have in there. And so I was really happy with the result of this, and I thought, well, okay, that's good. So here's my proof of concept. It worked great, and that led to this. And so now what we have here is I built a form and cast some carbon fiber cloth. Okay, like this was some real nice epoxy, and formed this shape out of carbon fiber. And I did that twice. I made two forms, and if you see on the end here, there's a layer of spruce going through here. So there's spruce stringers that are running the full length of this all the way up and into the head, and this is also spruce. And that is between, there's a layer of carbon fiber on the inside and a layer of carbon fiber on the outside. And in between the spruce strips, it's completely hollow in there, so this is unbelievably lightweight. And it's just a very, very rigid structure. It has very little flex or give to it at all. And so we have a nice little hollow neck. I don't know if you want to zoom in on that a little bit and see, get some of the detail of that. But it, here's the basic idea of this, and what we're going to do after I glue the top on is cut the slot in the side here and start playing with that and literally voice the instrument. So here's a carbon fiber neck. It was really hard to get the veneer to conform, so anyway, I did some fun things with that. But this is kind of a unique design because it's going to be a 5-string violin that it's just the fingering and the fingerboard and everything is going to be just like a traditional 5-string violin, and then this it has the addition of these little Goto stealth tuners, and so there's 5 on a side going in these little holes in the back of the head here, and these are for sympathetic strings that are going to be running under the fingerboard. So the next piece of this is a piece of extremely dry, pretty lightweight resonant western red cedar that I've fitted so that it is going to clamp into the neck here and set down in there just a little bit. And then I'm actually going to put this under torsion pressure. I'm going to clamp that down and glue it real good, and it's going to have this pre-tension in it. Then I'm going to carve the top and take some of that tension off of there, but it's designed to have that feature. So this is the basic body. There's going to be the slot is going to be a sound hole, and then there's a sound hole kind of coming out the end of the neck there where the peg head is, so sound's going to emanate out of that as well. So essentially the fingerboard's running the entire length of the instrument under the fingerboard. So here's our fingerboard. This is ebony, and it is completely hollowed out, and it's got 2 layers of carbon fiber cloth underneath it. So this is extremely rigid, very stiff, and it has this nice hollow function here. So after the soundboard is attached on there and fitted, the next thing will be to put the fingerboard on, and it's going to go like that, and there's plenty of room for 10 sympathetic strings to run between the soundboard and the fingerboard. So they're going to come out here, the strings are going to come out here and go through a double-decker bridge. They'll be highly coupled to the bridge, and I'm going to design it to be super springy on the base side there, having that nice angular fulcrum motion, and that's it. So this is a new concept electric violin design, and I'm pretty excited to get this thing put together and see how it performs. Everything that I have surmised so far tells me that it's going to be awesome. So super lightweight, and it's been a lot of fun developing this, and so anyway, just wanted to share that with you. Y'all have a wonderful day. Thank you.